Two more things, okay? From a long-term control of blood pressure, this is it right here, okay? There are three kind of, there's four major hormones that we have being secreted here that affects the body over the long term. Short term is great for, getting up and moving around and, interacting over the course of the day and maintaining blood pressure and blood flow to all of the structures, brain being the most important. Long term, though, that's when we get the kidneys involved, right here. That's when we're going to get the lungs involved. That's when we're going to get the liver involved. So long term, control of blood pressure is hormones, hormones, hormones. Why is excessively high blood pressure so detrimental on the body, on you as an individual? Well, I mean, as you can kind of see here, the liver does so many things. The liver does processing of nutrients, make them bile, helping to recycle old defective red blood cells. There are some Kupffer cells within it that will be phagocytic in nature, so cleans the blood a little bit. And it also makes, as you can kind of see, angiotensinogen. So it does a number of different things. And if you're going to have excessively high blood pressure, well, or excessively low blood pressure, now we're going to get activation of a number of different structures. So liver, kidneys. Kidneys filter the blood, help to maintain blood volume. It's going to get involved here. If you have the lungs are going to be involved. Okay. And I believe COVID is, I think there is some linkage into affecting this specific enzyme with individuals with the COVID nonsense. That it attacks these structures within the lungs, these that are involved with ACE, and it's affecting the individual to maintain some effective blood pressure regulation. So there's a lot of things that COVID does in the body. And, this is why, having breathing issues or having blood pressure issues is such a important comorbidity to, if you do have that, to understand that and try to practice social distancing and try to wear a mask at all times when you go out in public to lower your exposure to that to that crazy bug. All right. But the major hormone regulation for blood pressure is this renin-angiotensin system. All right. We have the liver makes angiotensinogen. Okay. It's kind of like this precursor to what we're going to see here. As soon as the liver dumps that into the blood, it's going to travel around the body. All the blood gets filtered through the kidneys. Kidneys will see the angiotensinogen, and the kidneys will produce what's called renin. This is going to be in response to a very low blood pressure, okay, or sympathetic activity. Either one, okay. And sympathetic activity is usually done in conjunction with low blood pressure. Well, renin helps to make angiotensin 1. And this is all happening within the kidneys. Okay, so we get that conversion of angiotensinogen to angiotensin 1. It doesn't get filtered out. It stays within the blood, leaves the kidneys, and continues to circulate around the system. Ultimately, all the blood not only gets delivered, to the kidneys, but it gets delivered to the lungs. Here I have my ACE enzyme, my angiotensin converting enzyme, and it helps to convert angiotensin 1 to angiotensin 2. Where does this occur? In the lung. So I have the liver making angiotensinogen. I'm winking. I have the kidneys releasing renin, making angiotensin 1. And then within the lungs, I have another secretion, another enzymatic secretion helping to transform angiotensin 1 into angiotensin 2. Angiotensin 2 is a potent raiser of blood pressure. Raises the blood pressure, okay? It is a potent raiser of blood pressure. It raises the blood pressure within the body in a multitude of ways. It's important to understand these four major things here. It is a vasoconstrictor. Blood pressure is dramatically dropping down. Low blood pressure, okay? So angiotensin 2 is going to act on the blood vessels to vasoconstrict. And vasoconstriction leads to increase in resistance, which is going to increase blood pressure. It also acts on the brain into some reflex centers that actually stimulate thirst. So you're going to go find that water jug and you're going to start drinking that jug of water. This increases fluid intake, obviously, and this increases blood volume. And if I increase in blood volume, what happens to blood pressure? It raises. It also acts on the kidneys. It actually causes the kidneys to not form as much urine. It causes you to hold on to that blood volume, reabsorb water, okay? So you hold on to it. You keep it in the blood more. You keep it within the system more. This helps to, again, raise blood volume, which raise blood pressure. It also stimulates the release of a couple other hormones. Hormone on hormone on hormone on hormone on hormone action. Hormones are long-term regulators of blood pressure. Angiotensin 2 gets converted to it within the lungs via that ACE inhibitor. It causes vasoconstriction. It causes you to go find water, stimulates the thirst center. It causes the kidneys to retain more water. And it causes the release of aldosterone and antidiuretic hormone. It does also a number of other hormones as well. I am just asking these two, okay? There's atrial natriuretic peptide, which is done by the heart. There's a number of them, all right? I'm only asking aldosterone and antidiuretic hormone, okay? Aldosterone is released from the adrenal gland. It increases the absorption of sodium. By increasing the absorption of sodium, wherever sodium goes, water goes. Okay, so if I absorb sodium back into the body here, water follows with it. Water stays within the system, which your circulatory system, decreasing urine output and increasing blood volume and increasing blood pressure. Look familiar? Okay. Antidiuretic hormone is released from the posterior pituitary gland. Actually, it's secreted by the hypothalamus or produced in the hypothalamus and stored in the posterior pituitary gland for release. It increases absorption of water in the kidneys. It stimulates thirst center as well to increase fluid intake. And if it's dumped into the system in huge amounts, it can cause vasoconstriction. Which is what angiotensin 2 does as well. What do all of these hormones do? decrease urine output. Causes you to reabsorb a hell of a lot more water. Triggers you to go find water. All to help maintain this blood pressure. And this is what happens over the long term. Short term, chemoreceptors, baroreceptors. Okay. But over the long haul, several days, hormones are going to get involved in this process. Your diet's going to have a huge effect on blood volume, blood pressure by sodium intake. Excessively high consumption of sodium is associated with high blood pressure. And its presence there will do all this stuff. Atrial natriuretic peptide, the other major one that I didn't really put in here, it counteracts all this stuff. So not every hormone is going to be a stimulator of reabsorption of water, or a stimulator of vasoconstriction, or a stimulator of thirst centers. There are a number of hormones as well that counteract all these. These are the most major ones, though. Okay. Understanding who secretes aldosterone, who secretes antidiuretic hormone, those are always good questions to ask as a multiple choice. Understanding aldosterone's function to increase absorption of sodium ions, which helps to increase water absorption, increasing blood volume, increasing blood pressure. That always makes a good question on an exam. Antidiuretic hormone increases reabsorption of water within the kidneys to maintain that blood volume. Okay. Stimulates thirst center. Raising blood volume. All of this dictated by this renin-angiotensin system. Starts in the liver, converts in the kidneys, converts in the lungs. And as soon as that happens within the lungs, we get vasoconstriction. I get stimulation of the thirst center. I decrease urine output because it affects the kidneys. Secretes aldosterone, secretes antidiuretic hormone, which increases absorption of sodium ions, which helps me to increase absorption of water. Can also vasoconstrict and stimulate thirst centers as well. So we have a vast amount of hormones that will help maintain blood volume. You should know what blood pressure is. It's 120 over 80. I think we talked about that earlier. No higher than 120 over 80. It's slightly less, technically. Systolic over diastolic is what blood pressure is, measured in millimeters of mercury. Okay, that was a number that I said that you should know. What is high blood pressure? Technically anything over that, but chronically high is what I'm looking at. Chronically high is deemed 140 over 90. And it's that bottom number you don't want that one high at all. Hypotension, low blood pressure, anything less than 90 or less than 60. Okay. Anything less than 90 over 60. Orthostatic hypotension is low blood pressure when you stand up suddenly. So if you get up too quickly and you're like, whoa, get really, maybe a little bit of lightheadedness, that's what that is. It's just a blood pressure drop that was not corrected soon enough for whatever reason. Okay. Baroreceptors didn't kick in soon enough. And there could be a number of different causes for that: medication, infections, viral infection, bacterial infection, whatever the case may be. There could be a number of reasons for it. But blood pressure regulation did not occur quick enough. And generally, it's maybe just a one-time thing. Okay. If it's happening over and over and over, that could be an indicator of potentially very low blood pressure, and you should have you should go to the doctor and have yourself checked out.